In this second episode of our mini-series CICD and Infrastructure as Code, we are going to see how to create immutable artifacts for our Terraform code. Hi, I'm Anto and this is Out of DevOps. In the previous video, you may find the link up here, we discussed how to separate the code from the configuration. So we wanted to have our Terraform code completely isolated from the configuration. So we managed to externalize the configuration using YAML files. So we have all our configuration in a YAML file, and then we pass that configuration to the Terraform code with the YAML decode function. We can read that configuration and then apply all the variables. While it is nice to have YAML because it's more readable, readability is not the only reason to do this. So the other thing I mentioned in the previous video was the 12-factor app, and in the third factor, what they suggest is to strictly separate the configuration from the code. There are a number of advantages with this. One, you can have your configuration living with the environment, so the application, when deployed, can fetch the configuration parameters directly from the environment. And also in this way, you don't store configuration parameters and values in your code. But why we want to apply this principle that is specific for application development to infrastructure as code? I think if you look in Terraform, there are 5 different ways to pass values to the resources. So you can hardcode them with the resource. You can use variables, and when you define a variable, you can put the value in as a default value. But you can also pass in the var.tf file or the outofdevops. And the other way is you can pass the vars on the command line, or you can even pass the variables on as environment variable. So all these ways create lots of confusion, especially during review, because when you are reviewing the code, you may not have all these ways in your pull request. So you may have part of them are part of the pipeline, and it becomes really difficult to understand which value in the end is going to be applied, because each of them has they have their own override mechanism. So separating the code from the configuration helps us to have a single place where we can look at the configuration and a single place where we can look at the code, and also we can have some sort of injection of our configuration instead of looking at so many different places. So now that we have this mechanism, let's see how we can do a step further and try to create an artifact that can accept our configuration file. So we get two things. We are trying to create an immutable artifact, so we can promote this artifact across environment, and we can also enforce the configuration mechanism using this artifact. So there are different ways to create artifacts. A very simple one is to create a zip file. I think a zip file is easy to do, but it is not very flexible. One thing I like to do is to create Docker images containing our Terraform code, all the dependencies, so all the modules and the providers, and the Terraform executable itself. Now we're gonna see how to create the Docker image containing all of this. So on the same repo, I created a new folder that is called Dockerization. And under this folder, I'm gonna show you in a second, there is the same Terraform code that we used the last time, and there is a Docker file. So let's start with the Docker file. I'm not sure if you're familiar with Docker, but in this example, we're gonna do a multi-stage build. So we're gonna have 3 stages. We're gonna use 3 different images. So we're gonna use the Alpine image, the Terraform image, and in the third stage, we're gonna use the Scratch. Scratch is it's a special image from Docker that essentially is a base empty image that doesn't contain anything. So if we start from stage 1, we have our CA certificates. These may be useful because are generally used by Terraform to validate the SSL certificates, and that's why we are updating them, and then we'll copy in the last stage. In the second stage, we pull all our dependencies. So what I'm doing here, I am cloning our Terraform Google Cloud Storage. So do you remember in the previous video we were cloning this on the command line, and we are also checking out a single branch, which is the single tag, the 3.1.0. At this point we have to copy a number of files. So one of them is providers, and I'll jump on this in a second. Then we have to create 2 directories. One containing mirrors and one an empty directory that will be clear later. So now why we're doing this mirrors thing. So the Terraform since version 0.13 introduced the new command, which is Terraform providers mirror. And this command allows you to create a local mirror for Terraform providers. So what we're going to do when we run this command, we're going to pull during build time all our providers, and that I can show you now. So the providers are defined in the providers.tf. So that's why we are copying the file first. We copy this file in this folder, tf providers. We jump in the folder and then we call this. And at the end of this command, in the /mirrors, the folder that we created here, we're gonna end up with all our providers. So now we can fetch providers from here, and we don't even need an internet connection, so a connection to the registry.terraform.io. Now, after pulling all our providers, what we're gonna do is copy the rest of our files. So we're gonna copy the wrapper, which is under modules. So we're gonna copy this here, and then we're gonna copy our main file that is the same as last time. The only thing that I changed is the input file, because now we are storing everything under config on the root. So now at this point we completed stage 2, we pulled all our dependencies, and we can start with the packaging. Before I start with the packaging, there was another mechanism in Terraform before Terraform 13 that was called Terraform bundle. You can find under the main GitHub repo of Terraform, there is a folder with tools, and you can search Terraform bundles. If you go on a previous version, you can use that one instead of the providers mirror, because it may not work with previous versions of Terraform. So Terraform bundle should allow you to do a similar thing. You can look at the documentation on GitHub, but the recommended way is to use providers mirror, because the Terraform bundle has been deprecated, so it won't be available in the future. So now let's look at the stage 3, the packaging. So as I said, we're gonna start from the scratch image, and this scratch image is essentially an empty image, and we have to copy all the things that we pulled in the previous images, like certificates and our providers and our Terraform code, into this image. So what we're gonna do, we're gonna copy from the different stages. So we're gonna copy from certs, we're gonna store under the default certificate location, and then we're gonna copy our TF folder that contains all our Terraform code, our mirrors. This is needed because, as I said, Scratch image doesn't contain anything inside, so this is and it doesn't contain any folder structure. So Terraform, when runs, it requires the temporary folder, and when this is not present, it fails. It took me a while to understand that this was the issue. So now I created the empty folder in the previous step, and now I'm cloning that so we can have a mount point for this directory. And the other thing which is important to note is the Terraform RC. So this Terraform RC works in conjunction with the providers mirror, because in this file we are defining the file system mirrors. So we are telling every single time there is a provider from Google or from random, use this and don't use this. So direct, we are excluding from fetching directly from the original sources, and we are instructing Terraform to get them from a local file system. So now if we go back to this, I think the last thing we're doing is copying the Terraform binary from the previous image to Scratch. So now in this we have packaged an image that only contains Terraform, our providers, and our modules. So now we can build our Docker image, and we can run it. So to run the image, before we run the init command, what we're going to do, we're going to create a volume. So this volume is called tf working directory. So now this volume will be mounted with all our images, with all our containers, so we can have the same, we can share the same volume where we can store the Terraform workspace. So now, if you see, there are a couple of things to notice. So we are passing a Google application credentials variable, and what we are doing, we are also mounting our volume with the working directory. So now everything will happen in this directory. Our configuration will be under the /config. So in this directory we have our service account, which is read-only, and also we are configuring our backend config. So I'm using GCS as a backend, and we are passing from module. So we are essentially initializing something that lives in another folder into the current folder, which is the working directory. So when I run this, what we get all our modules initialized. So now all these have been initialized locally. What we can do, we can run our plan. So the plan is very similar, and we are mounting the same variable, we are mounting the same volumes and the same credentials. Now we are also passing the input file, which is a file that we have locally, and we are saving the plan in the working directory /plan. So when I run this, we should get this request hitting Google. As you can see, we got all our resources, the plan for all our resources. So now at this point we can simply apply. So to apply, same thing, just do apply and then working directory /plan. So now what we have done, we have created a Docker image with all our Terraform code and all the dependencies that can even be executed in a air-gapped environment, so where you don't have connectivity to the public internet. And we are also following a principle of continuous delivery, which is the immutability of the artifacts. So our artifact now is immutable, the configuration is injected or passed by a file that is externally managed. And now we can even create a process for building these artifacts and promoting the artifacts across environment. So in the next video, we're going to see how to test this artifact and how to promote across environments. And that's it for now. Hope you liked it and see you soon. Bye bye.